Today, it's all about LIDAR technology.
A LIDAR technology is based on bouncing a spot of light off an object, measuring the time of flight.
I mean, as Elon Musk said in 2019, he said that by the end of 2020, we'll see level 5. Didn't happen.
And the Tesla paradigm is that cameras and radars can improve to the extent that you will not need a third sensing modality.
Welcome back to another episode of Matrix Tech Talk. Today, it's all about LIDAR technology. Well, it's actually more than that. We're also going to talk about IPO, how to take your company public. And for that, I have a super exciting guest all the way from California, Aditya Srinivasan. Aditya, welcome to Matrix Tech Talk.
Thank you very much. Appreciate the opportunity.
Amazing. I'm so excited for this talk today. So Aditya is an electrical engineer and computer scientist, studied in Indian Institute of Technology, Bombay, and he has a glorious career. I mean, I don't know where to start and where to end when I would start talking about Aditya's career. So I will let him talk a little bit about himself and his passion. Before that, Aditya works for Innoviz. It's an exciting company, and they're on their way to go public with a valuation of $1.4 billion. And as I understand, they make LiDARs. So that's about today's Tech Talk. It's about LiDAR. Of course, we're going to touch autonomous vehicle technology with LiDAR, safety, security, all that kind of stuff. And we're super curious to know the process of IPO. Aditya, without further ado, why don't you tell our audience a little bit about yourself, your passion, your background, and what got you here?
I grew up in India and went to college there, did an engineering course, and was one of the first batches of computer science students at the engineering school. And then, at that time, the 80s, actually the 70s, I'm very old. In the 70s, most of my classmates came to the US to study further. I stayed in India. I worked at a fledgling computer company. And then a couple of years later, Xerox built a factory in India, and I joined them as a manufacturing engineer, helped them put together that factory. And it was super interesting to learn from a third world perspective how modern production is done. At that time, modern, of course. I then worked for IBM in India, stayed there. And then a Bay Area, a Silicon Valley startup company in video processing hired me to run their engineering center in Bangalore. This was late 90s, 1998, when the technology revolution in India was just starting to happen. So we were in Bangalore, and Bangalore was just almost a retirement community at that stage, unlike the bustling city it is today. And it took off then, and it was a lot of fun to see that growth. I moved to Silicon Valley in 99 with that startup, which was right place, right time. It was the beginning of the flat screen revolution. We were a chip company. We had sterling customers in the Far East, Sony, Samsung, NEC, Fujitsu, and so on. And I transitioned in that time from an engineering role to a sales and biz dev role, and have stayed in sales and, on the dark side in sales and biz dev ever since. The company was a chip company. I stayed in semiconductors and video processing for 20 years. In several different startups, most of them unsuccessful, few of them successful, and stayed in biz dev. And then worked at one stage for an Israeli company, also in video processing. And that's how I got introduced to Innoviz, which is a company in the LiDAR space, headquartered at Israel, where our R&D is. It's a very strongly R&D oriented company. And that's, I moved from video processing to LIDAR technology, which is fairly adjacent technologies.
Thank you so much. You have already touched some very stimulating points. Let me start with a controversial issue that Elon Musk's radical viewpoint on LIDAR. And we do have not only Elon Musk, we have a bunch of LIDAR bashers, and we have LIDAR companies. So what's your take on that? Let's start there.
Our CEO put it very well when in a recent LinkedIn post, he said that Elon Musk was absolutely right about what he said about LiDARs at the time he said it, which was a few years back when LiDARs were extremely expensive. The flagship product from Velodyne at that stage cost north of $100,000. And at that price, it's much more than the price of a car. So why would you put a sensor on a vehicle when it's that expensive? Today, companies like us who have taken that same LiDAR technology and in physical terms shrunk it, in electrical and technology terms converted it to solid state, there's been a revolution in how LiDARs are designed. From being spinning mechanical machines, which are very, very prone to failure, they've been converted to semiconductor-based sensors, which are robust. And most importantly, the most fundamental change besides cost and size, cost and size obviously matter tremendously, but even more important, LiDARs today, the LiDARs we're building today, comply to the ISO 26262 standard, which is the base requirement to have a sensor in a vehicle. And, 5 years ago when Elon made that statement, he was looking at LiDARs which were not automotive grade, which did not have functional safety baked into them. Functional safety is a formal analysis of failure mechanisms in a vehicle. It's a very formal methodology to decide what are the key attributes a functionally safe component in the vehicle must have. And it cannot be designed as an afterthought. You cannot build a sensor and then bake in functional safety or automotive grade compliance. It's got to be thought about at the very, very start of your design. And every component in the sensor has to be designed with functional safety and ISO 26262 in mind. As an example, we have a large chip. We call it Maui. It's a 16 nanometer, fairly significant piece of silicon, which was designed by Innoviz engineers. Now, that chip has to be designed from day one with functional safety in mind.
At this point, I can't help asking you some interesting question, because you mentioned evolutionary pathway of LiDAR technology from mechanical device. Remember those time when we had those Google car and they had this thing on top. First of all, it looked aesthetically ugly, and it was like $200,000 back then. Right? And yeah, a nice little research project, but it's not going to happen in real life. Now, what you said that LiDAR costs are now, the Innoviz LiDAR costs are hundreds of dollars. So it's a significant reduction. And mechanical to semiconductor based design. What was the mechanism for LiDAR when it was spinning? And what was the kind of like 1.0, 2.0, what was the evolutionary pathway till here when we have absolute semiconductor based? And how does that work?
A LiDAR technology is based on bouncing a spot of light off an object, measuring the time of flight. So you send a blip of light, it hits a wall, let's say 100 meters away, and comes back. So it's traveled 200 meters. The speed of light is a constant. And if you measure the time that the blip of light took to get there and back, you can calculate the distance. Now, that gives you one point in space, but you want to see the whole field of view. If you think of a camera, it sees it sees what our eyes see typically. So a driver wants to see the road. The automated car needs to see the road. So you have to take that blip of light and move it around the field of view in some way. Now, that movement is done in a mechanical, in the rotating LIDARs. If you remember the spinners on the Google cars, as you said, they had a bunch of LIDARs. So if I have 4 fingers, that's 4 laser range finders. So 4 lasers are firing, and each of them is firing a blip of light. It comes back. You have 4 measurements, and therefore you get 4 lines. And if this is rotated, and this is exactly what the spinning LIDARs did. They stacked at the first, the original ones had just 1, then they had 16, then they had 32, then they had 128 laser rangefinders. They took those 128 lasers and spun them in a circle to scan the 360 around the vehicle. Now, what that means is there's a mechanism to take those stack of lasers, spin them around at speed, at 10 revolutions per second typically, and you put that stack of spinning lasers on top of the car. Because, and the reason it was on the top of the car, and as you rightly pointed out, was terrible industrial design. But the reason it had to be put there was it's spinning 360 degrees, and if you put it anywhere else, it's not going to see 360 degrees.
Makes sense.
Now, you take this concept of time of flight and you say that, okay, I need to shrink this. I need to make it a lot more reliable. How can I do it? And, you do it with mirrors. It's not smoke and mirrors, it's real mirrors. So if I take my cell phone and say that it's like a mirror. Now, if I move this left and right, and if I shine a light onto it, if I shine a light onto it from there, the light bounces there and comes back. So if I move this left and right, I will scan a single line. At the end of every left to right, if I tilt the mirror a little bit and then scan, I now have like a zigzag. For those of you who are from the old school as I am, that's called a raster scan. That's what we used to have in CRT devices in up to the 90s till flat screens came along. So with a raster scan mechanism with a mirror, you pivot the mirror to move it left and right and up and down. And with that, you're able to scan the field of view. Now, the little trick that Innoviz did was to make that mirror a micro mirror on a MEMS device. So it's a semiconductor chip on which is grown a mirror and by deposition. And most of the projection systems you see have systems with 1 million mirrors on them, million miniature mirrors on them to be able to project the image. We don't have 1 million mirrors. We don't say how many we have, but we have a few mirrors. And they work in synchronism to scan the horizon, the field of view. So we have 4 lasers and we have a set of mirrors. And with these, we're able to scan the field of view. And we don't do it 360 because you can't spin this mirror around, right? You can only move it to a degree. So we get the same field of view that human eyes do. It's about 120 degrees. See, we can see about that much. So our vision is trained to look straight ahead, which simulates highway driving. We have a field of view where we can see on the peripheral to some degree. We can't see 180 degrees very well. So the LiDAR we have put together is a scanner which can see 115 degrees wide, 25 degrees vertically, and that is plenty to be able to drive safely in the forward direction. Now, if you need to see with LiDAR at the back and at the sides, you would add more sensors. Mm-hmm. So that's the transition from the mechanical spinner to solid state, in our case, has been done with mirrors.
Love it. The transition is in the solid state. However, you're doing some kind of mechanical movement too, right? All right. Got it. Fascinating. Now, I want to go back to the controversy a little bit, radar versus LiDAR. Now, what are the use cases, so that our audience kind of like, we're clear on that. We absolutely need LiDAR technology that we cannot cover with radar or camera. Can you talk a little bit about that?
So camera, like the human eye, is a passive device. Passive in the sense it doesn't emanate light unless it's a flash camera. So you think of cameras, if you take a regular camera without flash, it's exactly like the human eye. It collects photons of light coming in. And it's got a perception system. The camera, behind the camera is intelligence. And behind our human eyes is intelligence as well, which absorbs light coming in and recognizes images, obstacles, threats, etc. from that. We just talked about the LiDAR sending out laser pulses. So it's an active sensing system, which is in a way like a flash camera. It sends out light. So the difference is when you have a passive sensing system, it's dependent on how much light comes in and the quality of light that comes in. So there are two cases where it absolutely fails. One is extremely low light conditions. You're at night, you don't have your headlights on, or headlights in a car are trained to be focused slightly. You're in Germany, so the same as the US. So they are trained slightly to the left so that they don't blind oncoming traffic. And it's a cone. This is by law. And headlights also have a limit of about 100 or 110 meters of illumination. Because again, you don't want to blind traffic. So deliberately, there's a limit on how much light you throw out with headlights and what direction you throw it in. So there are cases where you're driving on an autobahn at 200 kilometers an hour, and a deer runs across the road in the distance. And if you look at braking distances in an autonomous vehicle, the vehicle has a reaction time. It's got software that runs. It's got to make intelligent decisions. And then it's got to brake in a way that is safe to other vehicles. So there is a braking distance. And this stopping distance is well over 100 meters. So there's low light conditions where cameras fail. There's also extreme harsh sunlight. Think of yourself in a tunnel. The sun is low on the horizon and the sun is shining into the tunnel. As you come to the tunnel, your eyes get blinded. You really can't see what's beyond the tunnel. Now, when you're driving on an autobahn, you don't expect anything to be there. So you're okay. But if there is debris on the road, let's say something's fallen off a truck ahead of you, a pallet has fallen off a truck. A pallet is pretty small. It's 20 centimeters high. So let's say you got a wooden pallet, 20 centimeters high, fell off a truck just at the exit of the tunnel, and there's blinding sunlight. The camera simply cannot see it. It's blinded, just as human eyes are blinded by bright sunlight. A LiDAR, on the other hand, because it's sending out active light, and we have some videos which are posted on YouTube and at LinkedIn, which show this. A camera is blinded by that location of sun and the combination of sun and tunnel, but the LiDAR can see there. So we're not at all, the industry is not at all making a case that LiDARs are the only thing that you need or LiDARs solve all problems. No. Just as we human beings have 5 senses and we use all of them. When we're driving, we use multiple senses. We use our ears, our eyes, So in the same way, an autonomous vehicle needs multiple sensing modalities. And when you're driving at speed, our radar, LiDAR, and camera, all 3 have different conditions where they excel. But when you put them together, you get a safe, a robust system.
It's interesting. The other day, I was actually, I had a guest. It's coincidence that that was from a radar company. And the claim that was coming from my guest in my podcast in that episode was we can actually cover scenarios, as you've mentioned, with radar technology, with sophisticated radar technology. We don't need LIDAR. The scenario that you've mentioned is very, very exciting because we had real life incidences in that particular scenario, the sunlight scenario. This is a big deal, right? And a LIDAR technology can help. I am fully with you. The question is, can this be done with a radar or a combination of fusion of radar camera? Why do we need LIDAR?
Radar is constantly improving, just as cameras are constantly improving. And the Tesla paradigm is that cameras and radars can improve to the extent that you will not need a third sensing modality. Mm-hmm. It's possible. 10 years from now, does the world need 3 sensing modalities, 2, or is it going to be 4? I don't know. It has to evolve. But today, and in the foreseeable future, radar has a few limitations. One limitation is resolution. The radars are constantly getting better resolution, but they are not yet there to be able to see something which is, let's say, a 20 centimeter obstacle on the road, on a highway, at a distance of 150 meters. The resolution of radar is not sufficient yet to see that obstacle. The second limitation of radar, again, today, is a radar does not see some materials. I'm not an expert, but I believe wood and some other materials of that nature. It's exceptionally good at seeing steel, like in cars, but not as good with other materials. A third limitation in radar today is that it requires movement. So if something is stationary, it doesn't see it so well.
Doppler, yeah.
Radars are improving. They will overcome these obstacles or limitations, but not in the foreseeable future, which in the automotive industry is typically 5 years. You plan at least the production of a new series about 5 years before. That means you must have the sensors 5 years before you launch the car. And in that time frame, I don't see radars and cameras reaching that level.
I like that. I mean, besides all the points you've mentioned, relative velocity, Doppler is a major thing in radar. There's another problem with radar, which is interference, because you kind of like using the same frequency. How does LIDAR help in such scenario? Every
sensing modality has limitations. Now, a LIDAR, for instance, let's talk a little bit about the negatives of LIDAR. A LIDAR sends out light, which sends out a little spot of laser light, which has to reflect off an object 200 meters away. And the worst case for a LIDAR is a black car, because black reflects less. And a lot of cars are black. So a black car 200 meters away is kind of the worst case. Now, you make it worse by having bright sunlight. So the worst case for a LIDAR is very bright sunlight, a black car, and at a distance. Now, the interference that a LIDAR gets from the sun or from any bright light source, and there's nothing brighter than the sun, has to be overcome by very smart engineering, but you always get some interference. That's a different kind of interference we're talking about. You're interfering with the light. You're not interfering with the bandwidth. It's not the wavelength interference. And so, right? So the point I was making is that every sensing modality has interference or limitations. By having multiple sensing modalities which have different issues, you're putting together a system which is functionally safe. And to this point, just yesterday it was in the press that Tesla had some filings, and this is in the press, where the DMV, the Department of Motor Vehicles in the US, asked for formal declarations of safety standards, et cetera. And Tesla has formally declared that theirs is an L2 system, which means the human being has to be actively involved. And LiDAR technology, at least at this stage, before it evolves into lower levels of autonomy, today is targeted at L3, where the human being can go watch a movie while the vehicle is driving. The human being has to be engaged, sober, and available, but does not have eyes on the road and hands on the wheel in an L3 when the auto system is enabled. So the objective of human safety in that L3 environment is the standards are much higher for the automaton to be able to function than in L2.
To sum it up, it's really exciting stuff. One of the major limits of radar is the wavelength interference, which can be in such scenarios, LiDAR can be handy. And on the other hand, when you have this light interference like sunlight, where, as you mentioned, the worst case for LiDAR, black car and sunlight, probably we can use radar and fuse it, or sensor fusion, and take the best decision. I love that. And this is a perfect segue, as you've touched a little bit on functional safety. Let's talk about it. As you mentioned, your system is ISO 26262 qualified, certified. I mean, there are debates in the industry with this term, so I'm just going to be neutral on that. And thank you so much for mentioning that you got to start safety from the beginning. And this is what I try to make so many of my clients understand, that you can't give us a product when it's done and say that, we will get it certified. Safety doesn't work like that. Tell us a little bit about it, because safety in the semiconductor industry, it's challenging. Can you walk us through a little bit the process? What are the things that you look at? How do you test it? When we're actually qualifying an ECU, it's not a safety element out of context. We have the entire context. We have test cases we can run through, and we can really back our safety cases up with that. How does the semiconductor industry work in such process?
Your question is about the semiconductor industry rather than the sensor industry. Am I right?
I mean, you're on semiconductor sensor industry, because I want to know more about your process, your experience. I mean, kind of like your intuition for the audience. Sensor and semiconductor in a blend.
It's a very, very complicated topic. I'll give you almost a layman's understanding of it, because it's functional safety is an incredibly complex topic. But it starts with setting safety goals. And I found it fascinating to understand this, though I'm far from expert. But the way it's done is to say that, look, human safety, it's all about human safety. And the safety analysis starts with the vehicle engineers, the OEM, the manufacturer of the vehicle, breaking down the safety case and saying that, look, I want the driver to be safe, as in not killed. That's the goal. So you break it down into cases where things can go wrong, how often they can go wrong, and what's the impact of them going wrong. And you try to break that down from a very macro level of a person getting in the car and driving to work in the morning and driving home in the evening. And if he's on the same route every day, that's the most frequent route. So the probability there's are higher, and so on. You start from a very high level, but if you break that down with great rigor, go down to one chip inside the sensor. You go down to the sensor, the system level, the sensor level, one chip in the sensor. You can come down to, if you're an electrical engineer, come down to the level of saying, what if I had a dry solder on this leg of the chip? Would it impact, how would that impact the safety of the overall system? Now it's a very rigorous and demanding exercise, breaking down the functional safety case, analyzing it to a various set of threads, and then figuring out how the system will react with different failure modes inside the sensor. As an example, you have our chip has to be able to has to monitor itself. The chip inside the LiDAR has to monitor itself and monitor the LiDAR and be able to hold up its hand to the central computer in the vehicle and say, look, something's wrong. Don't use me. It's got to be able to monitor itself to the extent that it knows that it is failing and warn the central computer well in time. And that's in the order of milliseconds, that something is wrong. It's then that next level of intelligence got to figure out what to do. It could rely on multiple sensors. It could say, all right, I'm going to turn off the LiDAR and use the camera and radar. Or it could say, I'm going to come to a safe stop. I'm going to ask the human being to take over. There's many layers of redundancy, and having the human being in an L3 vehicle is the ultimate layer of redundancy for the central computer.
So what you're saying is really fascinating. So you're saying you have a hardware-based watchdog built in your sensor system that constantly is monitoring the health, so to say, of the sensor and communicating with the BDC, for example. The example you gave, like, which side of the chip, is soldered or not. If you do, let's say, a hardware fault tree, in this case for your product, it's gigantic, right? What is the order of magnitude are we talking about?
I'm not the person who has done that. It is a very, very complicated analysis. And fortunately, the auto industry has evolved over the, more than 100 years. And they have made a science of all this analysis. And the functional safe portion of an automobile goes through this kind of analysis, and there's safety analysis. It's complicated.
It's complicated. I'll touch base a little bit on the other aspects. We call our podcast Autonomous Vehicle Safety and Security Podcast. So we talked about safety. So when it comes to autonomous vehicle and you're taking external, input from external, there are possibilities of attacks. Safety is one, but there are possibilities of deliberate attacks. Is there any security mechanism that you have put in place in your product?
The auto industry has, looking at all the hacking that happens in the world and so on, has taken it tremendously to heart. The automobile of today, and even more so the automobile of tomorrow, is a network of computers. So there's a central computer which is controlling the entire vehicle. You have 30, 40, 50 microcomputers inside, distributed, doing anything from some vehicles. The front two seats have different small computers controlling just the movement of the seat. I mean, there's a lot more than that. There's infotainment, there's ECUs for firing the engine, for firing the cylinders. And then as you go into levels of autonomy, there's a bunch of little computers which are spread across sensors and the central computer. There's artificial intelligence running for perception systems. So there's an incredible quantity of computing in an autonomous system. And there is a diversity of little computers, big computers, and increasingly complex computers in a network. Now, as soon as you have a network, you have a threat from cybersecurity. The industry has really, I think, is evolving, but is doing a tremendously good job at making sure that these systems are secure. There's layers of defense, and every element of the network has to be cyber secure. So, the naive view is to say, hey, I'm just a LiDAR sensor and I'm not exposed to the world. Why do I need to be? No, it doesn't work that way. I'm a LiDAR sensor. I have to be completely proof against cyber attack.
What would be a typical attack deliberately toward the LiDAR? I mean, can we bombard the LiDAR with some kind of DOS attack? Can we bombard with some false signals or lasers? What would be a typical attack on the LiDAR itself?
If you want to do it physically from the outside with lasers, that's not cybersecurity. But the LiDAR subsystem that we have evolved looks at we call it the point cloud, a collection of points, which each point represents the distance of the object and the reflectivity of the object. Now, if I have a human being crossing the road 30 meters away, by looking at, let's say I get 10 dots on that human being or 50 dots on that human being, by looking at those dots, there's artificial intelligence running in the LIDAR subsystem, which says, oh, that's a pedestrian. That's a truck. That's a pedestrian. That's a car. That's a bicycle. And this is important because the software systems above us, if it's a pedestrian, they know that he or she is going to be walking at human speeds. Whereas if it's a bicycle, it's going to be going much faster. So they can predict the path that that human or bicycle will take better if they recognize the object. So I'm giving you an example. The LiDAR subsystem looks at dots, decides that something is a human, a cycle, or a vehicle, a truck, and classifies it. Now, that's a lot of intelligence to be able to do within the sensor subsystem itself. Now, a cyber attack might come in and say that, hey, you know what? You report every truck you see as a human. So the software layer above you gets fooled and thinks it's a human, plans for human speed rather than truck speed, and causes an accident. You know, they can be as subtle as that. I mean, they could be.
Got it. So when it comes to hacking, the thing that we are looking for is the interface to the external world. So one interface in a LiDAR system in the external world is the signals environment itself. And as you said, that will not be cyber attack. Agreed fully. Now the cyber attack is like, fooling the system with false answers, false AI, false positives, or what have you. Now, what would be the access point to that system? It's definitely not the lasers.
The LiDAR subsystem communicates with the vehicle computer over a network. It's just like the home network.
Is it Ethernet?
Yes, it's Ethernet.
Ethernet. Okay. And so that Ethernet is then the problem. So in today's vehicle, if we can get into the CAN bus, that's it. You can take control of the vehicle. So when it will be, Ethernet based, so the Ethernet will be the holy grail, and you can actually also got it. Car hackers will not be actually going to the sensor first, rather get into the vehicle network first, and then probably go and, hey, I want to, manipulate your system, maybe flash some malicious software and that kind of thing. Got it. And you definitely have, some security mechanism to protect this at that layer, right? Fascinating. Fascinating. I'm switching gear a little bit. I want to talk definitely about your experience of Innoviz from zero to IPO. How old is Innoviz?
5 years old now.
5 years old. That's so cool. That is like a baby. It's younger than our company, actually. So how did it get started? I mean, tell us a little bit about the story behind Innoviz.
It's a fascinating story. I wasn't there when Innoviz was born. The founders, the CEO who founded it, and he got together some of his comrades, really. They came from a unit of the Israeli army. In Israel, everyone goes to join the military for 3 years, men for 3 years, women for a year and a half after high school. And then they go to college. The Israeli military, the military intelligence, I'm not one of them, so it's easy for me to say, picks the brightest and asks them not to join the military after high school, but to go to engineering school, but join a special unit of the military after that, which does, advanced electronics for intelligence purposes. And this unit of the military, it's called Unit 81. Even that name used to be secret. Now it's public. A number of the founders and quite a large percentage of the R&D, especially the early stage of the R&D, came from that unit. And those people work in the military for 10 years after they join. And they work very intensely on building electronic devices for military purposes. The characteristic of those people is, first, by selection, they're the brightest. They are very bonded together because they work together in that unit and they have this sense of camaraderie. And they work with tremendous passion. I've not seen this before in my career, a team that works with such passion. And there's a very, I think the nature of that relationship that formed there is such that when there is something, when there's an obstacle or when there's a goal that must be achieved, and the obstacle typically is time, and it has to be done quickly, they really pull out all the stops. The energy, the creativity, and the intelligence that they bring, and it's a combination of all this and a way of working together without, it's not that there's no argument. It's not military in the sense of utter discipline. The Israeli mind is willing to argue, but when a decision is made, everyone marches, and there's tremendous energy unleashed when a group of intelligent people work together to build something. It's tremendous.
That is really fascinating. And that was 5 years ago. That was the founding history. And then all the way to IPO. When did the founders decide that they're going to go public?
One thing we've not brought up is it's important to understand that Innoviz very early in year 2 announced that we had a design win with BMW. And that was outstanding because we'd not built the sensor yet. We built a very early prototype, and BMW did a tremendous amount of investigation of our technology, and more importantly, of the team. They were really buying into, we didn't have a product at that time. They were really buying into the R&D capability of this team. And BMW, through Magna, who's a tier 1, awarded the iNext program to Innoviz. This shaped the company and created a focus on automotive grade, which we talked about, on automotive grade and functional safe sensor development. Then with this came the realization that it's a long path. It's building this kind of sensor is a long, it's a marathon. It's not a sprint. And to do a marathon, you have to have a lot. You have to carry a lot of calories. You have to burn a lot of calories. I'm hacking this analogy as we go along, but it's working. Now,
I like that. Yeah.
Those calories we found, obviously our money and people. And as we went along, we realized that it's going to take a lot of money to get to profitability. It's a long path in the automotive industry. We had raised by this time $250 million. The path to autonomous vehicles is long. 3 or 4 years ago, people were thinking that it'll be 2 or 3 years. It's not. It's going to be longer. The world will get there, but it's going to take time. And so we needed those calories. And we were, in a way, right place, right time. The SPAC companies came along. There was this financial revolution last year, where what we call blank check companies, basically investors, took an old concept.
Blank check companies, yeah.
But they took it to the next level, where the number of such instances went up quite dramatically last year.
True.
And so we were approached by a number of SPACs, and we finally made a deal. And it's not yet consummated in the sense that it's publicly announced. We have the process is that you are quoted and you quote a SPAC, which is a set of very smart investors who have put together $300 or $400 million and registered a company. So they've already got a company registered on NASDAQ. Then you have a deal to merge with them. That merger is a process where you take a startup company like Innoviz, which has technology, people, but is not yet got the stature to be public on its own. You have a public company, and you're basically putting these together. And in doing that, the startup company gets a very significant dose of funding. You also get listed. And now this allows the flow of investment to happen into the company, giving it the calories needed to continue development. And we will continue development beyond Innoviz 1, which is the current product, to Innoviz 2, which will, be significantly better performance and lower cost.
Love it. So just for our audience, a blank check company is you form a company and take it public with an idea that you will buy a company. So it's a blank check company. So you don't have a company, but you already take it public. And as Aditya mentioned that in the last couple of years, there was a spike of such a blank check company in the Wall Street. And once you go public, what you do is you buy a company like Innoviz, and then you run it. And that process is, for a startup like Innoviz, makes things much easier, right? I mean, you don't have to really worry about, you don't have to think about the complex and cumbersome IPO process. You just merge with an already existing IPO company. Is that a right way to see this?
A company like Innoviz, I mean, we talked about the genesis of Innoviz being a bunch of very smart engineers. Inherently, those very smart engineers are not Wall Street types, right? They shouldn't be. They should be innovative, creative engineering minds. So to look to those minds to engineer an IPO in the traditional way is hard. Typically, companies get to some level of growth, used to get to some level of growth, have a change of management, bring in the right people with the right culture to work with Wall Street and then do an IPO. It's different with a SPAC because you got mechanism of the registration with NASDAQ done already. You're putting the two together. It's really a funding event. It's a significant funding event for Innoviz. It's also taking it public. But the big news for Innoviz is that it gets very, very well funded and gives us the ability to go create Innoviz 2.
It's $1.4 billion valuation within 5 years' time, which is massive, especially in automotive industry. I mean, we're not talking about companies like, a SaaS company that scales almost infinitely. We're talking about physical product research and development. And within 5 years, $1.4 billion valuation is mind-blowing. And thank you for sharing the journey toward it. Now, when you were talking, it sounded like you're almost reading my mind. You mentioned that we're too early. I mean, as Elon Musk said in 2019, he said that by the end of 2020, we'll see level 5. Didn't happen, right? So my view is, there is no doubt that autonomous vehicle industry is an $8 trillion industry today. There is no doubt about it. It was exactly like in the 90s. I mean, internet was a huge industry, but it was not mature enough. People were not accepting it yet. I mean, there were some early adopters and Wall Street already betted on them, right? I mean, it would have been totally wrong if Amazon were a $1 trillion industry in the beginning of 2000 or late 90s. It was a bubble. Do you think the automotive industry, especially autonomous vehicle industry today, is a bubble if it is too early?
It's, of course, the jury's out on this and we won't know the answer to that for a few years. But I believe that the ramp to autonomy will be slower than what was predicted 2 or 3 years back. There's no question about that. That's already playing out. But having said that, I think the ramp will be slow but steady. We will see vehicles going through increasing levels of autonomy. The L2 plus or the ADAS systems today have a fairly high degree of autonomy. You can be cautiously unfocused once you engage your ADAS plus system. This will go into L3, where you can be consciously disengaged but available. And then it'll go to L4. So it's not going to jump, but the level of autonomy will keep going up. And the valuation of these companies will come from Innoviz will make a LIDAR sensor which goes into an ADAS system. So we will not wait. The industry cannot wait. And the sensor industry and the software industry cannot wait until full autonomy happens. So we will take the same technology that we have, shrink it in terms of cost, size. We will go into lower levels of autonomy to improve the functionality we can give to an ADAS system. And in doing this, we will scale the volume of sensors to the point where we are profitable without waiting for full autonomy. So I think there is a methodology for the autonomy industry to start making money even before full autonomy happens. And I think that might be the difference between us and the dot-com bust. I hope.
I love that. I love that that gradual, profitable way of moving forward rather than, a big bang that will revolutionize everything. I love that. With that, Aditya, it was lovely having you in the show. I almost had goosebumps talking about the stuff that we talked about today. I'm sure our audience is going to love it. So if you have liked the episode, please smash the like button and, subscribe to the channel. If you have questions, comments, if there's anything that you agree or disagree with, feel free to write in the comment section. Thank you so much, Aditya. It was lovely having you.
Thank you for the opportunity. It was great talking to you. Thank you.
Great talking to you. Thank you. Thank you very much for watching, and we'll see you in the next episode. Thank you so much for watching our video. Please click the link below to schedule a free consulting call with us if you need any help regarding the topic of the video. One of our staffs will get in touch with you and would be happy to schedule a free consulting call with you and happy to help you in any of these topics. Please click the link below now and we'll see you in the call.